Is it linear? Identifying linear functions from graphs, tables, equations, and situations. We'll start with new concepts and terms. A linear function has a constant rate of change. The rate of change of a linear function is found by dividing two outputs by their respective inputs. The graph of a linear function will be a straight line. In the table of a linear function, the change in y values over the change in corresponding x values will be constant. And the equation of a linear function will be in this form: y equals mx plus b. So let's start by looking at the graphs of linear functions. We are asked in this example to identify the graphs of linear functions. So out of the 6 graphs that are there, 3 of them are linear. Can you guess which ones are linear? The graph on the top left is linear because it has a constant rate of change and it is decreasing. The graph in the middle on the top is linear. The rate of change is 0. And the bottom right, it is a linear discrete function. The other graphs are not linear. For the one on the top right, it's made of several different pieces. Sometimes it's increasing, sometimes it's decreasing, so it doesn't have a constant rate of change. Same thing with the graph in the middle on the bottom. And finally, the graph, the vertical line on the bottom left, that is not a function, right? Because it does not obviously pass the vertical line test, so therefore it's not a linear function. Let's look at some tables next. We're asked to identify the tables of linear functions. Notice in the first table, as x increases by 1 each time, y is not increasing by the same value. So the rate of change is not constant, it is not linear. In the next table, as x increases by 1, y is also increasing by a constant, 4. This one is linear. In the next table, as x increases by 5, f of x is increasing by 7. Therefore, this one is linear. And in the last table, x is not increasing by the same number each time. So what we want to do is we want to determine the change in y over the change in x. Let's look at the top 2 ordered pairs. We're going to do 10 minus 2, that's the change in y, over 3 minus 1, the change in x. And we'll simplify that to 8 over 2, or 4. Now let's look at the bottom 2 ordered pairs. The change in y, 26 minus 14 over 7 minus 4. That's 12 over 3, which also equals 4. Therefore, this table is representing a linear function. Let's move on to equations of linear functions. Here we're given 5 equations, and we're asked to identify the equations of linear functions. It's really nice to use a graphing calculator, and you can use a free graphing calculator at desmos.com and just type these functions in, or these equations in, exactly the way you see them. So the first one looks like this, and y equals negative 3x plus 4, negative 3x squared plus 4, 5x plus 2y equals 10, and y equals negative 3x cubed. Of these, can you see which ones are linear? It's just the graphs of the straight line, right? There's only 3 of them that are linear. So now let's look at the equations. What do you notice about the equations that could possibly mean these are linear? Do you notice the x value? It's not being raised to a power. So that's how we'll recognize linear equations. All right, let's look at situations next. We're given a bunch of situations. And remember, we're looking for ones that have a constant rate of change. So take a moment and read each situation. There are two that do not have a constant rate of change. You notice the top two don't have a constant rate of change. But Cindy and her box of chocolates, every day she eats 2 chocolates, so the rate of change is -2 in this context. The restaurant that charges $8 for the first burger and $10 for the first burger and $8 for each additional burger, this rate of change is 8. The McNaughton boys are raking leaves for extra money. Their rakes cost them $50 to purchase. They earn $15 for each lawn raked. The rate of change is 15. And bottled water costs $1.25 per bottle in the school's vending machine. The rate of change here is constant and it's $1.25. So let's summarize all of the different representations we've been talking about. And here we have a context, we have a graph, a table, and 2 equations. These are all linear, and we want you to determine the rate of change for each linear function. So Mr. Jones put $22,000 into his bank account. Each month he withdraws $800 for rent. The rate of change is -800. So sometimes rate of change is positive, other times it's negative. In the graph, this is increasing, and the slope is 2, right? Because rise over run, up 2 into the right 1. The rate of change is 2. In the table, well, let's wait on the table. Let's go down to the equations. The rate of change in the bottom left equation, y equals -2x plus 5, that's -2. It's the slope. For the other equation, we'd have to write it in function form by getting the y all by itself. And now this rate of change is the slope, which is -1/3. And the table is not, the x's are not increasing by a constant value, so it's hard to determine at first glance what is the rate of change. Let's do the formula change in y over the change in x. Let's subtract the first 2 y values over the difference of the first 2 x values. So we have 5/1. And now let's subtract the last 2 y values over the last 2 x values. And we get 10/2, which also equals 5. So the rate of change in this case is 5. All right, we have a summary slide just to kind of put it all together. First we should look at our non-linear representations. Each of these is non-linear. Let's see if we can find out why. You can tell the graph is the easiest one, right? It's not, it is always decreasing, but not at a constant rate. It's not a straight line. All right, what about the equation? The x is not being raised to the first power. That's why this is not linear. If you scan the word problem, it doesn't seem like Mrs. Jones is depositing the same amount of money into her bank every month. So it's not constant. And let's figure out the change in y over the change in x in our table. Let's do the top 2 y values. Let's do 2 minus 3 over 1 minus 0. Let's simplify that. So it seems like the rate of change is -1, but now when we check the bottom 2 ordered pairs, the change in y over the change in x, the numerator here you see becomes -1 plus 1 or 0. and the denominator is -4, can you tell those ratios are not the same? That's why this table is not linear. So a summary of what we've learned here. In a linear function, there will be a constant rate of change. The rate of change is found by measuring the slope in the graph of a linear function. And the rate of change is found in a table by using the formula change in y over change in x. The rate of change is the m in the equation form of a linear equation, y equals mx plus b. And a situation that is linear will have a context with a constant rate of change. That is, the same process will take place repeatedly using the same quantity.